Transformations. So, if we've got our basic curves, the first idea I guess we looked at when we had those was shifting them around, moving them up, moving them down, and so on. So how do we shift those curves? We could have function x plus or minus a constant. Really, that should be written as y minus plus a equals function x, because it's the y value you're adjusting in this one. So you sort of group it with what you're adjusting. So a units up or a units down, depending on whether it's plus or minus. So all right, here's random curve y equals function x. So if I wanted to shift everything up a, so they all go up a, I get my new curve, which would be, well, technically it's y minus a equals function x, but we normally write it with y the subject, so we end up with y equals function x plus a. Now if it's grouped with the x then, that's when we have the horizontal shift. So if I wanted to move, here we go, everything to the left b units, so every single point is going to move along b, I get this new curve. Will that be y equals function x plus b? What's the shift? Well, when you've grouped it with the right pronumeral, you just ask yourself, what would make that equal to 0? So with the y equals function x plus b, well, negative b would make that equal to 0, so I've shifted it left, in the negative direction. With the other one, when I group it with the y, I'd get y minus a. What makes that equal to 0? Positive a. So I've shifted everything up. Then the next idea was, instead of shifting, how about we stretch them in either direction? And that's when we multiply by a constant. So if we multiply by a constant, again, technically, that's y divided by k, because you group it with the pronumeral that's going to be changed. So this is going to be a vertical shift because it's the y values that have been changed. And what should happen then, because really as I say over there it's y divided by k, if k is less than 1 we'll end up with a shallower curve. If k is greater than 1 we'll get a steeper curve. So something like that would be k times function x where k is greater than 1. In other words, every y value if you like we've multiplied by k. So hence we've got a vertical stretch. The y values have doubled, tripled, whatever k happens to be. If I was going to multiply it by a constant less than 1, I'd end up with this shallower curve. So it's like I've pulled it up or I've pushed it down, depending on what the constant is. Now when we do that, so when we're talking about vertical stretching, it has no effect on the domain whatsoever. Now, the range might change depending, in this case it didn't of course because it was all real y anyway, but depending on that. But the key points, the y values have changed. So these stationary points, yes the x values are still the same because we haven't done anything with the x, but the y values have changed. So everything's to do with the y, the key things. So the x-intercepts, they don't change, but the y-intercepts, they would. Now, if it was x divided by k rather than y divided by k, we're now going to get a horizontal pulling out or stretching or pushing in. Again, depending on the value of k. If k is less than 1, we should end up with a steeper curve. K is greater than 1, we end up with a shallower curve, which you'll notice is the opposite to the y one. So if I'm going to push it in, this is where k is less than 1. Because what we're basically saying is, hey, normally I would substitute x in, but now to get the same answer, I'm going to substitute in x divided by k. So say originally I substituted in x equals 5. Now k is less than 1, let's make it easy for ourselves. Let's say k was 1/5. So now I only have to substitute in 1. So it's pushed the whole curve in. I'm substituting in smaller values, if you like. Another way people think about it, instead of dividing by k, it'll be multiplied by k, but then in that case k would be greater than 1 instead of less than 1. And there's my one where I pull it out, so this time k would be bigger. Or another way of thinking about that, if it is constant times x, I tend to just think of it as x divided by k because then it's the same as the y divided by k. I don't have to think of two different things. But if you're ever unsure, again, just ask yourself that question, well, what do I substitute in now to get the same answer as I would have got before? So in this case, the range shouldn't be affected because all we're doing is stretching horizontally. So the y values of the key points will remain the same, but now the x values would change. So in this one, the y-intercepts would stay the same, but the x-intercepts will change. Okay, reflecting curves. So if y equals negative function x, that's going to be a reflection in the x-axis, because what was positive is now negative, and what was negative is now positive. So if that was my original curve, obviously the x-intercepts will stay the same because they've got a y value of 0. And so negative 0 is still 0. But let's reflect the key points. So my y-intercept, instead of being at negative whatever, will now be positive whatever. Stationary points, they're probably good ones to reflect as well. And so from there you can usually get a good graph there. There's minus function x. Function negative x then will reflect in the y-axis. It'll go the other way. Same sort of idea. The y-intercept will stay the same. But now my x-intercept over here will go into the negatives, and this negative one will go over into the positives. So if we swap them over, and what other key points we got? Oh, the stationary points. If I swap them over, and we'll get, there we go, there it is reflected in the y-axis. That's function negative x. Function 2a minus x. So what about if we want to reflect, still looking at horizontal and vertical lines, if I wanted to reflect in x equals a, it's actually 2a minus x. We would substitute in, not a minus x. It's 2a. All right. So basically we're going to replace x with 2a minus x. So there's the original function. I want to reflect it in the line x equals a. Okay. Well, any point on that line will stay where it is. And then I just reflect over again. I'll pick the key points. The y-intercept, reflect over. Those x-intercepts, reflect them through x equals a. Stationary points. And voila, we get a curve reflected in x equals a. So that's function 2a minus x, not a minus x. Whereas y equals 2a minus function x, not a minus function x, but 2a minus function x, will reflect in the line y equals a. So a similar idea, I'm replacing y with 2a minus y, if you like. So if I group that over, we end up with, let's draw it. There's a horizontal line, same idea. All the intercepts with that horizontal line will stay the same. And we reflect the key points. So there's our x-intercepts, I've just reflected over the line. And there's the y-intercept and the stationary points. And I would end up with something that's reflected in the line y equals a. Look, not a lot of questions there to try, but we'll have a go at those 8a and reflect over.